Hey guys! In the previous lesson, we understood how to multiply scalars with vectors. In this lesson, we will be doing vector multiplication of vectors, that is, when vectors are multiplied with vectors itself. Now remember, vector multiplication of vectors is of two types. One is called dot product of vectors, and one is called cross product of vectors. So let's say we're given two vectors, vector A and vector B. Dot product is represented as A dot B. Cross product is represented as A cross B. In both cases, we would do multiplication, but the way of multiplication is different. In each of the dot product and cross product, there are two ways to solve the question. So the first way is when the vectors are given in magnitude form. So let's say we're given vector A magnitude as 3. Vector B magnitude as 2, and we're given the angle theta. Theta is going to be the angle between vector A and B. So let's say it's given to us as 60 degrees. In this case, we would find out the dot product by just multiplying the magnitudes with itself of both vector A and B, that multiplied by cosine of theta. And the answer that we get is 3 multiplied by 2 cos 60. This gives us 6 times cosine 60 is half, that is equal to 3. So the answer of A dot B is 3. Now since we're not given any units, let's consider this is unit and this is also 2 units. So all we have to do is write on 3 units square because it's after the product we have got. So dot product of vectors when the two vectors are given in magnitude form, formula is A dot B equal to A magnitude multiplied by B magnitude multiplied by cos theta. This is the formula that we apply to find out the dot product when we are given the vectors in the magnitude form and we are given the angles separately. Now here one thing that we have to note, and that is very important, is that when the two vectors are perpendicular to each other, let's say this is vector A and this is vector B, then the angle between the two vectors is going to be 90 degrees and cosine 90 is equal to 0. So the dot product becomes 0 when the two vectors are perpendicular to each other. So from here we can conclude that dot product of the two vectors is going to be 0 when angle is 90 degree or when the two vectors are perpendicular. So this is an important thing to remember. Next type of dot product is when we are given the vectors in component or Cartesian form. Now if we are given vector A as 3, minus 2 and we're given vector B as negative 1, 5 and we have to find out the dot product of vector A and B. All we have to do is just multiply the x with x and y with y. So 3 times negative 1 is negative 3. Negative 2 times 5 is a negative 10. And we do not put a comma in there, we put a plus sign. So we basically add the product of x and y. So we get a negative 13 units square. This is also called dot product of algebraic vectors. So whenever we are multiplying the two vectors when they're given in component form, or Cartesian form or algebraic form, all we have to do is just multiply the x with x, y with y and add the x and y product with itself. If this will be in 3 space, we would have x, y and z, and that goes like this. A vector is 2, minus 1, 5. B vector is minus 3, 0 and 2. To find out the dot product of A and B, we multiply x with x, y with y, z with z. So 2 times negative 3 is a negative 6. Negative 1 times 0 is a 0. 5 times 2 is a 10. And then we add up all of these products. We never do any different axis addition or subtraction in any of the other operations of vectors. It's only the dot products where we are going to add up the x, y and z values. And only the products are the ones that we would add up. So we would get negative 6 plus 10, which is a 4. We can put it as units square. And this is how we find out the dot product when the vectors are given in component form. Next we have is cross product. So when we have to find out cross product of vectors, we write it as A cross B. Here also we have two ways in which the questions can be given. One is if the question is given in magnitude form. So if we're given A vector magnitude as 3, let's say meters. B vector magnitude is 2 meters. And angle is given to us as 30 degrees. The formula for cross product is A cross B vector is equal to the magnitude of each of the vectors multiplied by itself. So vector magnitude A multiplied by vector magnitude B multiplied by sine theta. So cross product is associated with multiplying by sine theta. We have vector A as 3, vector B as 2. sine theta means sine 30 degrees. When we put this all on the calculator, we'll be able to find out that 3 times 2 is 6 times sine 30 is equal to 3. Here we put in 3 meters square. So in order to find out the cross product given the magnitude of the vectors, we follow the formula. A cross B vector is equal to vector A magnitude multiplied by vector B magnitude multiplied by sine theta. In this case, we have to note that if two vectors are parallel, so let's say this is vector A and vector B, these two are parallel means their angle between them is 0 degrees and sine 0 degrees is 0. So if the two vectors are parallel, their cross product is 0. This is another important thing that we have to keep in mind. And how is it different from the dot product? Dot product is 0 when the two vectors are perpendicular. Cross product is 0 when the two vectors are parallel. So in order to find out the cross product when we are given the second way where the vectors are given to us in component form, let's say we're given the vectors in component form, we are straight away doing 3 space vector. Let's say vector A is given to us as 3, negative 1, 2. Vector B is given to us as 2, 5 and 2. Now to do cross multiplication of vectors or to find out the cross product of vectors, there is a different way of doing it. So basically every vector is going to have x value, y value and z value. If any value is missing, there'll be a 0 there. Now in order to find A cross B, we have to write down A first and then we have to write on B vertically. Here we can put their x, y and z values. So we're going to separate out their x, y and z values. So A x value is 3, y is negative 1, z is 2. For B vector, x value is 2, y is 5 and z is 2 as well. To find out A cross B, we would technically get the new x, y and z value. And to get that, the new x value, remember, so if you're working on the x value, we're going to leave the x value hidden. We would be multiplying y and z's to get the product x value. And how do we do that is, we take the top y value or the y value of A multiplied by the z value of B. So we do cross multiplication. So negative 1 multiplied by 2 minus 5 multiplied by 2. Negative multiplied by 2 is a negative 2 minus 5 multiplied by 2 is a 10. To get my y value, I would now be hiding my y value. So I would be working on z and x. So multiply the z top number with the x bottom number. So always remember top number multiplied by bottom number of the next coordinate axis. So if we're finding a value for y, the next coordinate axis is for z. So z top multiplied by x bottom. So 2 times 2 is 4 minus 3 times 2 is 6. Next we're looking for the z value. So we would now multiply x and y. So top value of x multiplied by the bottom value of y, which is 3 times 5 is 15 minus 2 times negative 1 is a negative 2. Now we would simplify this. So we get negative 12, negative 2 and 15 plus 2 we get is 17. For cross products, we're not multiplying x, y and z values. We will be leaving them as coordinates. If you're asked to find out what is the magnitude of the cross product, so all we have to do is we will be doing negative 12 square plus negative 2 square plus 17 square and square root the whole thing. So it's basically x squared plus y squared plus z squared, square root the whole thing. Then we put this result in the calculator and we would be getting our final answer. Here we get 144 plus 4 plus 289. When we put this all in the calculator, we get 20.9. And we can put this as unit square. And this is how we get the cross product of vectors when we're given the two vectors in component form. Let's summarize everything. So vector multiplication is of two types. One is called dot product and one is called cross product. One way of finding the dot product is we multiply the magnitude of the given two vectors with the cosine theta. Theta is the angle between A and B. This gives us the dot product of A and B. Another way is that if we're given the components AX, AY and we're given the vector B components bx, by and we have to find out the dot product. We just have to multiply ax, bx added to ay, by and we would get the dot product. For finding cross product, if we're given the magnitude form, we just multiply a and b vector with the sine theta, where theta is the angle between a and b, and that would give us the cross product of a and b. Another way is if we are given vector a with ax, ay and az coordinates and vector b with bx, by and bz coordinates, then the cross product is going to be equal to aybz minus azby, comma azbx minus axbz, comma axby minus aybx. And this is how we would get the new coordinates for the product of a and b in the form of a cross product.